Hello, my name is Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 4, Lesson number 3 on exponential function basics. Most of what we're going to do today will be review from Common Core Algebra 1, but given that you had that year of geometry in between the two, we think that it's important here at eMath Instruction that we get you up to speed on what an exponential function looks like, how it behaves, and how you can tell that behavior by simply looking at the equation. So let's jump right into two graphing exercises that really show how exponential functions behave. But first, let's take a look at their general form. All right. Exponential functions, y equals b to the x, where b is the base. Remember, these are functions like y equals 2 to the x, y equals 1/3 to the x, etc., right? So 2 to the x, 5 to the x, half to the x, 0.75 to the x, right? All of these are exponential functions because the base is a constant and the exponent is the variable. Note that in every single case, the base is positive. You will never have a negative base as an exponential function. You'll never have something like y equals -3 to the x. All right, that will never happen. But the base will always be positive. It could be greater than 1. It could be between 0 and 1, but it will always be positive. All right, clear out that little bit of writing. And let's jump right into it. All right, exercise number 1 says, consider the function 2 to the x. Fill in the table below without using your calculator, and then sketch the graph on the grid provided. So I would like you to try to make an attempt on this, okay? Pause the video, take about 5 minutes to try to graph one of the most basic exponential functions, y equals 2 to the x. All right, let's do it. Well, let's start with the easy ones. When x is 1, 2 to the first is obviously 2. When x is 2, 2 to the second is 4. And when x is 3, 2 to the third is 8. Now notice in each case what we're really doing is we're multiplying the previous output by 2. Therefore, you could go in the opposite direction by dividing each output by 2. Of course, we should know that 2 to the 0 is 1. And we should also know that 2 to the -1 is 1 over 2 to the first, or 1/2. Right? 2 to the -2 is going to be 1 over 2 squared, or 1/4. And likewise, find a little space down here, 2 to the -3 will be 1 over 2 to the third, which will be 1/8. So let's plot these. Again, I'm going to start with the easy ones. 0, 1, that's a pretty simple one. 2, 4, 1, 2, 2, 4, 3, 5, 6, 7, 8. Now for the fractional ones, -1, 1/2, and 1/4, and 1/8, right? So we'll get something that looks kind of like this. Years ago, I had a student in calculus call this the hockey stick graph. Right, it goes up very quickly and then levels out towards the x-axis. So there it is, y equals 2 to the x. We should be able to handle those negative exponents, those positive exponents, that 0 exponent. We could even have some fractional exponents in there too, but who would really want to deal with 2 to the 1/2, right? The square root of 2. Ugh. Anyhow, copy this down, pause the video now, and then we'll move on to one where we use our calculator. All right. Clearing it out. Now, y equals 2 to the x might be the most basic exponential function where the base is greater than 1. Let's look at an exponential function where the base is less than 1, where the base is 1/2. Now here it asks us to use our calculator to help us fill out the table and sketch the graph on the axes provided. So let's do it. Let's bring out the TI-84 Plus. Ready? All right. There it is. We're going to just create a table of values, and it's going to help us out. So let's hit y equals. And let's put that function in there kind of the way it looks. Let's put the 1/2 in parentheses. You could, of course, just put 0.5, but if it were a fraction you weren't as familiar with, you'd want to put it in parentheses, so that's what I'm going to do. Put 1/2 in parentheses, and then I'm going to raise it to the x. Make sure you do that. Don't just have 1/2 times x. That's a linear function. So now I've got 1/2 raised to the x. Now I need to go in and do a table setup, right? So let's go into our table setup. Let's make our table start at -3, and let's make it go by ones, right? Because that's what my table goes by. All right, check that out. Make sure it all looks good. And then let's go into the table, which we can access right here. All right, we're now into the table. So now it's just a matter of writing things down. So for -3, what we see is we see an output of 8. For -2, we see an output of 4. For -1, we see an output of 2. For 0, no great surprise, we see an output of 1. For 1, we see an output of 0.5, which is of course just 1/2. For 2, we see an output of 0.25, which is 1/4. And for 3, we see an output of 0.125. That's less common, but that's 1/8. So let's graph it. -3, 1, 2, 3, 4, 5, 6, 7, 8. -2, 1, 2, 3, 4. -1, 1, 2, 0, 1. 1.5, 2, 1/4, and 3, 1/8. There's probably no way I'm going to draw a good smooth curve through this, but I'm going to take my best shot. You guys all know how bad I am at this. And there we go. Now, of course, that exponential function decreases because its base is less than 1. And it makes sense. Every time we multiply something by 1/2, effectively, we're dividing by 2. So we're making the quantity smaller in that case. All right. I'm going to put away the TI-84 Plus for right now. We might need it a little bit later, but let's get rid of it now. All right. Pause the video, copy down anything you need to, and then we're going to move on. Okay. Let's clear it out. Okay. So, exercise 3 says, based on the graphs and behavior you saw in exercise 1 and exercise 2, state the domain and range of an exponential function of the form y equals b to the x. See, the thing is, when you have y equals b to the x, right, it either looks like this if b is greater than 1, or it looks like this if b is less than 1. But its domain, right, the input set, well, that's all real numbers. There's absolutely no value of x you cannot put in there. I mean, we now can handle 0. We can handle positive exponents, negative exponents, fractional exponents. But the range, that's a little bit different. Notice that in every case, the outputs we always got were positive numbers. Positive outputs. We never got an output of 0, and we never got a negative. And that will always be the case. The range is y greater than 0. If you really like interval notation, it would look something like this, 0 to infinity. All right, but not including the 0 and not including the infinity. All right, this is pretty important stuff, so pause the video now and write down anything you need to. All right, let's clear out the text. Are exponential functions one-to-one? How can you tell? What does this tell you about their inverses? All right, pause the video now and think about this. It hasn't been that long since we've done one-to-one functions, so think about whether exponential functions are one-to-one. All right, well, remember what a one-to-one function really is, right? A one-to-one function means that different x's, that different x's give different y's. So no y's get repeated, right? Well, if you think about their graphs, right, whether it's an increasing exponential graph or a decreasing exponential graph with a random mark there, right? Because they're always increasing or always decreasing, they are definitely They're definitely 1 to 1. You could also use what's known as the horizontal line test. Remember that? Passes the horizontal line test. And remember how the horizontal line test works, right? It says that if you take any horizontal line, let me draw it in red, right? And it hits the graph at most once, right? It never hits the graph twice, then it's 1 to 1. Now, possibly the most important thing, what does this tell you about their inverses? It tells you that their inverse is also a function. Or perhaps grammatically speaking, I should say the inverses are also functions, right? All functions have inverses. The question is whether those inverses are also functions. And exponential functions, that will be the case. Now, we won't see their inverses for a little while, but they're going to be a very important part of this course. So pause the video now and write down anything you need to, and then we'll move on. Okay, clear out the text. Let's take a look at another one. Exercise 5. It says, now consider the function y equals 7 times 3 to the x. Letter A says, determine the y-intercept of this function algebraically. Justify your answer. Okay, fair enough. Well, why don't you go ahead and try to find the y-intercept algebraically. See if you can remember how to do that. All right, let's do it. Well, to determine the y-intercept of any function, right, I don't care what it looks like. The plain fact is, for the y-intercept, the x value is 0. So let's see what we get. Y equals 7 times 3 to the 0. Now remember your order of operations. That multiplication by 7 comes after we raise the 3 to the 0 power, but 3 to the 0 is 1. So we just get 7. That is our y-intercept. Isn't that cool? That's our y-intercept. Now letter B, does the exponential function increase or decrease? Explain your choice. Well, think about this for a minute. This exponential function increases because its base, 3, is greater than 1. All right? It's all about whether the base is larger than 1 or less than 1. Please don't get wrapped up, as some students do, thinking about it's whether or not the base is fractional or a whole power. Not a whole power, but a whole number. That's a terrible way to look at it, because if I have a base of 5 halves, even though that's a fraction, the 5 halves being greater than 1 will mean the exponential function will increase. Now letter C, it says create a rough sketch of this function labeling its y-intercept. Well, here's the thing. All exponential functions that increase essentially look like this. The only difference really is how fast they increase and where they cross the y-axis. But that's it. That is a perfectly good graph of this exponential function. All right. Well, I'm going to clear this out in just a bit, so pause the video now, and then we'll move on. Okay, here we go. All right, exercise number 6. Ooh, this one's a bit different. Consider the function y equals 1/3 to the x plus 4. How does this function's graph compare to that of y equals 1/3 to the x? In other words, what does adding 4 do to a function's graph? Think about that for a minute. All right, let's talk about it. It will shift, or you could use the word move. It will shift the graph of y equals 1/3 to the x upward by 4 units. Letter B. Looks like we've seen this one before. Determine this graph's y-intercept algebraically. Justify your answer. All right, go for it. All right, take a look. Again, y-intercept means x equals 0. So let's just put that in. We'll get 1/3 to the 0 plus 4. 1/3 to the 0 is 1 plus 4 gives me a y-intercept of 5. Letter C says, create a rough sketch of this function labeling its y-intercept. Well, this is a decreasing exponential function, but normally 1/3 to the x would look something like this. I'm going to draw it in dashed. This would be what 1/3 to the x would look like. All right, so this is y equals 1/3 to the x, and it would have a y-intercept at 1. But what we've done is we've shifted everything up 4 units. 1, 2, 3, 4. I'm going to draw another dashed line. I'm going to also put that 5 on there, because this is what our new function looks like. All right. Instead of getting, sorry about that. Instead of getting smaller and smaller and approaching the x-axis, it gets smaller and smaller and approaches the horizontal line, y equals 4. All right. So we've shifted our exponential function upward so that it's no longer leveling out at the x-axis, but leveling out at a different horizontal line. All right. Pause the video now if you need to, and then we're going to clear this out and finish up. Okay, very good. Here we go. All right. Well, in today's lesson, we probably reviewed a lot of things that you saw in Common Core Algebra 1. Probably we didn't see anything new at all. What we wanted to do was review basic characteristics of exponential functions, the most important one being the fact that the base, and whether it's greater than 1 or between 0 and 1, dictates whether the exponential model is increasing or whether it's decreasing. This is very similar to what the slope of a linear model tells us. You know, if the slope of a linear model is positive, it increases. If it's negative, it decreases. Here, when the base is greater than 1, it increases. When the base is between 0 and 1, it decreases. And then there was a lot of other stuff thrown in there as well. All right. For now, though, I want to thank you for joining me for another Common Core Algebra 2 lesson by Math Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.